Now we're going to be using the node we created in order to control the origin of a function. Now, with the node the way that it currently is, the origin control isn't sensitive enough. And the node we created is to reduce the sensitivity of our vector, but the way we have designed it so far is really for a number input. So let's take a look at the node we currently have and the modifications we need to make to not only fix the offset to work correctly, but also just to increase sensitivity of our movement. And you'll see what I'm talking about in a sec. What I want to do first is just demonstrate our current setup and how this is going to work with two objects. What I have is a cube I've loaded into the scene, and if we go to the numeric tab, select our position, I'm going to change all of the values to 0, so we have 0 on all axes for position. Now I'm also going to add in a sphere to the scene and do the same thing. So we have a sphere and a cube, both at 0 all axes for position. What I want to do is control our sphere with our cube. So we're going to select the sphere, open its graph, and we can load in the meta node we had created. And I've got a couple of tests I just set up, but basically the range controller is what we've made. So what we're going to do is select to connect our position for our sphere to this node, and our controller, we want to select our cube position. Now at the moment, what's happening is, because the way the nodes are set up, our scene internal unit is basically destroying our offset and is making the output not sensitive enough. So if we select our cube and start to manipulate it, we can see the sphere has only moved a very small amount. And now any input we're going to add to our vector range is only going to reduce the amount. In other words, the motion we have on our cube is going to affect the sphere even less. So what we need to do is correct our origin and set up a different type of offset to recorrect it for the vector so that we have some control, or a little more control, with our vector range. And now the reason we do want to have this sort of reduction is because when you're working with especially material origins or any sort of fractal origin, small movements can really affect a material. So we do want to be able to reduce the motion from an object so that we don't have to zoom in really close to our object and make them really small, and that's just going to be really hard to manipulate and make any sort of animation changes or have control within the interface. So what we need to do is fix our offset, and we're going to go into the node and just make some changes. What I want to do in this case is just close out these objects while we're making these changes. We don't want to have any sort of interference. And I just opened the graph for our ground plane so that we can work on the node. We'll load this back in, our range controller. I'm going to click Edit. And what we need to take a look at is what is causing this issue. And basically it's because we're grabbing our vector for our vector output from our internal unit correction. Well, that's primarily for manipulating numbers, which is great for modifying the blenders like we did before. But right now, we need to focus on the vector, and we're going to be using this as an offset to control different nodes and offsetting them in a couple of different ways. So we kind of need to preserve our vector the same way it is, but we still want that link to the internal unit. So we basically need a direct connection to our external dependency and rework the way this is going to affect our dependencies. But we still need that offset amount that we have to work correctly. And that way we can position objects in the scene where we want them and not affect the controls. So that's important. Otherwise, all we would have to do is just connect this directly to the output. But we do want this offset to still be taken into account, and we don't want to have to change the values. So instead of using 10 meters, we have to use 100, because then we can no longer use this to control numbers. So what we can really easily do is create a new set of nodes. And first what we need to do is have a constant vector. So I'm going to add in a constant vector, and that is going to control our offset. So instead of publishing this vector as our offset and this offset node, we're going to connect the vector to our constant vector. And I am going to make this a connectable constant vector. Once we made that connection, we lost our published value because we can no longer modify it. So now we can publish this value as our offset. So now what we want to do is offset our vector group by adding in a math node, vector operations, offset. We can connect our decomposer we have to this offset, and then connect the offset amount to the constant vector. So now our published offset amount, which we can see in the primary node, is going to affect both of these offsets, even though they're on different outputs. One for the vector output, and one for all of our number outputs. And what we basically need to do is reverse this internal unit correction. But only with the offset itself. So what we can do is move this offset over, and we're going to connect it to the external dependency, which is whatever we want to use as the control. And instead of setting this up where we have the multiply by 0.1 value directly on our main link and modifying the entire output, we only want to modify the offset, which is pretty easy to do. And this time what we're going to be using instead of a multiply is a divide. So we're going to add in a combiner node, since we don't have the divide function available for our math node, and we're going to be using two different types of connections. So our offset first needs to be connected to this blender, and basically our offset amount that we have extracted. We can now connect this to our constant vector, and I'm going to change this to the divide function. In this case, what it did was removed that connection, so we'll just reconnect it. So now we need to divide by this number. As you can see, we can't connect it. So we basically need to do what we had set up before, but a little more simplified. We're going to add in a math node, vector operation, composer 3. So now we can take our vector and take 3 number outputs to make the vector. And this way we're affecting the entire XYZ vector output. And all we need to do is connect all of these connections, and there's 3, input 0, 1, and 2, to the number we have published as our internal unit. What this will do is return the value back to a correct vector amount. Because before we were working with numbers, the outputted amount didn't need to be converted back to a vector. But now that we're working directly with the vector output, we basically need to multiply it. And in other words, if we entered in a value of 10, that works for a number to represent 10 meters, but that would come from a vector of 100. So now when we enter in an offset of 10, it will add to our vector output as a value of 100 to work with that correctly and bypass the internal unit. So now this is basically set up and ready to go. And we now have a control of our vector range to be able to limit the amount of movement, along with being able to use our offset correctly for our controllers. So let's go ahead and test this out. And I'm going to use the exact same setup I had before, just a cube and a sphere. I also want to go ahead and just save this. And just because I don't want to modify the old version I have, I'm just going to give it a new name of _offset. So now we can remove this from our ground graph. We're going to add in a sphere, add in a cube, and they're already at the position of 0, so we don't need to worry about modifying that. And we just want to control this sphere once again with the cube. So we can load in the new meta node, connect our position, and have the control based on our cube position. And now we're going to notice a lot less of a reduction in the output. So we can take our cube and we can move it, and it's matching up perfectly. So at the point where it's actually inside the object. So now we have a full control over the origin without losing what we had before, but still tied to our internal unit, and we can also make our offset work. So let's take a look at how that offset is going to work. Our cube, we're going to set back to 0, which is also going to take our sphere and set it back to 0. But what I want is to have our cube 10 meters on the y. So we'll type in 10 meters on the y. But what that's actually going to do is modify our sphere. Well, we want this to be our starting point and a non-controlling value. So in other words, we're changing the origin of our cube without it affecting the sphere. So we can go into our sphere, edit the graph, and just like we had set up before, we have our offset. Set this to -10, although either value of 10 will work really depending on which direction you're going to end up moving the manipulation. In this case, we do want to do a -10 to get this to work correctly. But now you can see that we have the offset working. So now let's work on the limiter and the sensitivity amount. Grab our sphere, go back into the node, and now we can set our vector range. Now this range is going to work differently than it does for the numbers. For the numbers, we would set an amount equal to the total amount of range. Since we're working with origins and offsets, it's going to be a little bit different. So what I want to do is take our vector range and set it to 2. Click OK. We select our cube, and we're going to move it on the X 20 meters, which is going to basically divide this in half. So we type 2, and now we have half of the amount. If we go to our sphere, we have 10 meters instead of 20 meters. So it cuts it in half. In other words, 2 steps to equal the total position, and that's our range. So let's go ahead and change this a little bit more. Select our sphere, vector range 10. Now we take a look, and we have 2 meters. So a total amount, 10 steps to equal the distance between the offset and the output. And this gives us a really good sensitivity control when manipulating origin or anything else we want to manipulate with the vector, and it's all tied in directly to this node. So a higher number will decrease the sensitivity that we have within our motion, allowing us to move the object further without it manipulating the vector as harshly. So we change this down to 5. And now we're going to see when this updates, we've got 4 meters. We're basically just setting the amount of steps it takes to get to that full vector. So it's a really nice control that we have. If we were to take away our offset, then we're going to see this sphere jump over, but not quite as far, because we still have that sensitivity amount set. And go to our sphere, we're going to remove our offset amount, and now we can see it has moved over on our y, but only 2 meters, because the amount of movement between the two is 10. So the vector range that we have, of course, works differently than the number output, but is still very effective and a way to reduce the amount of motion and increase the amount of range we can use within the scene to manipulate objects to affect a vector. So now that we have this node corrected, we are ready to apply this to a couple of different functions and create something pretty cool.